Hi, this is Bonspiel PDX, a Capstone project sponsored by the Evergreen Curling Club here in Portland, Oregon. I'm David.
I'm Frank.
My name is Jean.
I'm Aaron.
I'm Tejas.
Hi, I'm Noah.
In this video, my team and I will showcase Bonspiel PDX, which is a full-stack web application designed to be used as a tracking system for curling tournaments, otherwise known as Bonspiels. Here's a quick demo for our application.
The target audience for our web application is curling enthusiasts. This includes the members of our sponsors organization, Evergreen Curling Club, as well as curling club attendees and curling fans. The target age demographic spans from children to seniors, so we made sure our web application was accessible and user-friendly. Our web application has two main features. The first feature is for all visitors of the site who want to look at Evergreen Curling Club's current Bonspiel information. This includes details about ongoing games, scores, participating curling teams, event schedules, and general curling event information. The second feature is for the administrators, specifically the Evergreen Curling Club's curling event coordinators, who need the ability to create, update, or delete specific curling event information. The main page of our application navigates to the most recent draw of a particular Bonspiel. On this page, the visitor is able to see the current draw, as well as the scores for the games that are in the draw. The current standings for the entire event are also easily accessible from this page. In the sidebar, the visitor is able to see the current event, as well as past and future events. The other main feature is for the administrator, who manages curling events, games, teams, and curlers. The admin logs into a separate page that allows them to manage information on various components of a curling event. Overviews of all curling events are easily accessible in the admin dashboard. This includes general event information, all the way down to individual game information. The admin is also able to batch upload information about an event by downloading, filling out, and submitting a spreadsheet to the web application. If the admin needs to make slight adjustments to an event, they can do so by accessing the sidebar, where they can add, edit, or remove any detail about an event. There are two levels of administrative access, a regular admin and a super admin. The super admin has all the capabilities that the admin has, plus the additional ability to manage admin access.
As seen in the demo, batch upload is an alternative method to upload an entire curling event at once. The curlers, organizations, teams, draws, and games via a template spreadsheet filled out with required data. The customer benefit for this was not having to use the front-end interface to create an event from scratch each time, as they usually have similar configurations and the data should be reusable. Also, for consistency, the batch upload was to be made atomic so that any validation, syntax, or SQL error could roll back the upload for the entire event. Also, as the process was error-prone due to the large amount of inputted data, a user-friendly error response was also important, and this required some tweaking of the backend architecture to pipe error responses from the large volume of data validation for all the backend routes. Given that the different event entities are also closely linked, relationships between rows in sheets were mapped using in-sheet references, which were resolved into database IDs during the parsing process. Due to the complexity in the dependency relation in the table design, the upload process needed to be correctly ordered per curling entity and also per upload row in the case of games that are connected to one another in a bracket curling event. There were initially some disagreements on the design due to the inherent complexity of the problem, but through a healthy process of sponsor communication and feedback, the team settled on a method which was a good compromise between usability and design restrictions.
Another key feature of our project is the administration component. The administration features are only allowed to be accessed by authorized users. Authorization is done via JSON Web Tokens. Finally, user passwords are hashed and salted before being stored within the database.
we still have some features under development or not have a chance to start it. This list is what we'd like to implement in the future: the email notification, a more comprehensive encryption system, support the photo for color or organization, and a test suite for the project. These features are still just in our plan, but for the bracket visualization, we already had a prototype.
As part of our project development, we will discuss in detail our front-end, back-end, and database architectures, as well as our chosen tech stack.
These are the technologies we used to create the website. The front end of the website was built using Angular, and we deployed it using Heroku. Angular Material and Bootstrap 4 was used to design the user interface and user experience. The backend was built using Node Express. For the database, we used PostgreSQL on an AWS regional database server. We used Docker so that everyone could have the same environment when running the website locally, and GitHub for version control.
The architecture of frontend established on modular design. Total 2 modules exist in our front-end project, which are visitor and admin modules. Each module contains different components. For example, the admin page contains different function components, site navbar, dashboard components, and others. Visitor module also contains 3 different page components. Besides this, there are other components such as the login component, instruction component, and others. To write these components, we implemented the Angular service and material, and used the Bootstrap to construct our page.
On the backend, we have a Swagger REST API to serve public and admin routes. Admin routes to modify and add table data needs to be invoked with authenticated JSON web tokens, but the public GET routes are not protected in such a way. The architecture is such that a Postgres pool of clients are generated up to a maximum of 20 at the same time and dispensed once for each connection to the backend. The cap on the connection prevents overloading the database and frees up clients once they have been served. The architecture also supports chaining such that client pool objects can be passed from class to class for transaction-aware routes and coarse security enablement. And for coarse security, it works such that the dev backend only accepts requests from the dev frontend, and the production backend only accepts connections from the production frontend. Another cool security feature of the backend is its auto refresh, which needs to be triggered before JSON Web Token expiry for continued access to admin routes. The frontend is provided back a renewed JSON Web Token every 10 minutes, which means that minutes of inactivity automatically signs the user out, but if they do interact, they are able to visit any page of the website and still come back to the admin section to find themselves logged in continuously. Next, we also kept the backend modular by separating the service layer with the express routes from the business layer with the validation and data access logic. The query-specific logic was also put into a separate file to improve code maintainability and debugging.
From the start, we wanted the database to be persistent. Rather than require the admin to remake teams and curlers for every event, we wanted it to be possible for them to enter that data once and reuse that same data for future events. This influenced our choice to limit the duplication of data within the database. We made sure that each table was as independent as possible and kept combination tables to a minimum. This allowed us to keep things like teams and curlers from being tied directly to curling events. Another of the issues we had to carefully work through was setting the cascade option on certain attributes. This allowed us to have any deletions cascade throughout the database so that when something like a curling event was deleted, it would properly propagate and delete all the draws and games that were in that event. It took a few attempts to get that completely right.
The first step in our development process was when we decided to use an agile development process to quickly bring up a minimum viable product. This worked well, especially since our application is web-based, and we were able to quickly spin up a skeleton web application for the sponsors to visually look at. We had bi-weekly sponsor meetings that allowed us to calibrate our progress with our sponsors' expectations. The next improvement in our development process that our team took was when we decided on a set feature delivery schedule. We decided to deliver features to production every 2 weeks. Having a promised feature delivery deadline enabled the team to plan out which features were viable for development and which features would most likely be out of scope. Moreover, the promise of a new feature every 2 weeks heightened the communication between the team and the sponsor. Finally, we created a feature delivery schedule. This feature delivery schedule outlined which features were being worked on and which features were going to be worked on. Moreover, this schedule quantified the amount of effort that each feature took, and it allowed the team to efficiently prioritize tasks. Furthermore, having a feature delivery schedule increased the communication between the team and the sponsors. And I think this was especially beneficial for the team to understand the scope of each feature. During development, we decided on a Git workflow that involved a master branch and feature branches. Feature branches branched off from the master branch, and pull requests were made in order for the features to be merged into the master branch. Our team was mainly split between two groups, the front end and the back end. The front end dealt with the creation of the application client, while the back end created the API. Each team had their own design meetings where we decided on the high-level designs of the application. We coordinated development between the front end and the back end through our weekly scheduled Zoom meetings and Slack. Finally, we used GitHub Actions to deploy our application onto Heroku.
In terms of front-end development, David acted as the Scrum Master while making contributions to the login interface as well as the overall front-end architecture. Jean developed the main visitor page in addition to admin functionalities. She was also our sponsor liaison. Frank helped design and implement the schedule and team pages, and he also helped develop many of the admin functionalities. In terms of backend development, Aaron implemented the user authorization system for our application and developed many of the backend routes. Noah was instrumental in designing and maintaining the database for the website. And finally, Tejas created many of the backend routes and designed the batch upload feature. He also acted as our sponsor liaison alongside Jean.
During the project development, our team did have some unexpected events. Firstly, the most widely known problem is COVID-19. There's no person meeting anymore. All the meeting and communication moved online. Although Zoom and Slack helped us solve the problem, but it's still not as good as a meeting in reality. Another two problems are Heroku outage and AWS RDS backup. The Heroku problem happens because the free space is limited for our free account, and our project running and testing using resources that were beyond the limitation. Therefore, we have to create a new account and transfer the project to a new account. The AWS RDS backup problem is similar. Because the auto backup is too frequent and uses space beyond our imagination. So we reset the backup setting and solve this problem.
As Aaron mentioned, we had meetings with our sponsors every 2 weeks. These typically occurred a couple days after each sprint, so the sponsors would have a few days to see the updated features on the deployed site. Our first co-sponsor said that they were impressed with our ability to share frequent jobs, listen carefully to feedback, and adjust our plans accordingly. Our second co-sponsor said that the team had demonstrated a willingness to learn about the sport and the business by delivering Bonspiel PDX feature document with clear deliverables.
Finally, we learned several important lessons from completing our Capstone project. Firstly, we found that it was very difficult to accurately estimate how much time our developers will spend on a specific feature, especially when unexpected circumstances and issues arise. We learned that doubling our time estimations is a pretty good idea. Secondly, we learned that it is important to get customer feedback early on in the development process, as it will help drive the direction of our approach to design. Communication was key to keeping everyone engaged and informed, especially during these difficult times with COVID, when much of the collaboration is done remotely. Thanks for listening to our presentation.